Good morning. It's August 7th, and this is your daily brief in science. Here's everything you need to know. Two NASA astronauts outside the International Space Station conducted Spacewalk 96 to prepare for the seventh of 8 IROSA solar arrays, part of a larger effort to boost the station's power generation. The EVA is linked to an ongoing power-up sequence that will culminate with the final IROSA deployment later in 2026. The operation features Anil Menon on his first spacewalk and Jessica Meir on her sixth, as they upgrade solar arrays, replace a space-to-ground antenna, and lay cables for power and data. The spacewalk began around 8:33 a.m. Eastern Daylight Time and lasted about 6 hours and 27 minutes, underscoring Expedition 75 activities with 2 more United States spacewalks planned in August for power and data relay work and antenna replacement. NASA will provide live coverage of the spacewalk via the NASA Plus app and YouTube, with the operation streamed across nasa.gov/live. The mission highlights ongoing upgrades to support extended human presence in low Earth orbit and ties into Artemis-era plans, reflecting decades of ISS operations. 2 additional spacewalks are scheduled for August 13 and August 25, focusing on communications and electronics maintenance, with participating astronauts yet to be announced. So far, 6 of 8 IROSA assemblies have been deployed since 2021. The 3B power channel was the focus of this EVA, with 2A at left slated for future deployment. Meir wears a suit with red stripes for identification, while Menon's suit is unmarked. Meir is a seasoned spacewalker, and this is Menon's first EVA, with assisting crew monitoring from the ground. The IROSA program augments existing solar arrays to boost power by roughly 20% to 30% when used with the legacy panels. The August sequence includes Spacewalks 97 and 98 as part of a 3-step campaign to upgrade power, communications, and other systems aboard the aging ISS. Menon arrived at the ISS in mid-July and is set for an 8-month stay conducting experiments and routine station operations. Tuft cells are emerging as a key feature across several cancers, defining a non-neuroendocrine subtype of small cell lung cancer driven by POU2F3 and its Tuft cell networks, and hinting at unique vulnerabilities. Similar Tuft cell-like signatures appear in lung and thymic cancers, suggesting a cross-organ molecular class with implications for diagnosis, prognosis, and targeted therapies. Though effects vary by cancer type and stage, analyses using TCGA show higher POU2F3 expression in cancers such as cervical squamous cell carcinoma, cholangiocarcinoma, esophageal carcinoma, stomach adenocarcinoma, and thyroid carcinoma, with lower expression in prostate, kidney, and head and neck squamous cell carcinoma, indicating tumor-specific Tuft cell programs. A 2026 review in Genes and Diseases by Mengling Ye and colleagues synthesizes mechanistic and translational implications of Tuft cell-like tumors and outlines avenues for future research and clinical impact. In pancreatic cancer, Tuft cells may initially suppress tumor formation via prostaglandin D2, but oncogenic KRAS-driven inflammation reprograms them to promote progression, confer stem-like properties, and contribute to treatment resistance, including possible neural-like progenitor states linked to poor outcomes. Pancreatic Tuft cells thus show a dual role: early tumor suppression through prostaglandin D2 production followed by pro-tumor inflammation and stemness under oncogenic signaling, with possible neural-like transdifferentiation indicating aggressive disease. In colorectal cancer, Tuft cell signaling supports immune suppression and cancer stem cell maintenance, fueling metastasis and resistance via modulation of the tumor microenvironment. Gastric cancer involves Tuft cell-driven cholinergic signaling, including acetylcholine and nerve growth factor, promoting tumor development, nerve-tumor interactions, and inflammation. Disrupting these circuits shows anti-tumor effects in models. Across gastric and colorectal cancers, Tuft cell activity shapes the tumor milieu through cholinergic and immune modulatory pathways, suggesting potential therapeutic avenues by targeting these networks. A new collaboration aims to expand access to patient-derived iPSC models for C9 or FR7-related ALS and FTD, connecting patients, researchers, nonprofits, and industry to accelerate research and treatment development. The partnership seeks to remove barriers and speed up discoveries by building a shared resource that supports both academic and industry efforts to study disease biology and test therapies. A framework for patient engagement will accompany the model, enabling broader participation across research sectors. A portion of program proceeds will support CureC9's mission, with patients and families invited to contribute biological samples to grow the repository. The initiative includes ongoing patient engagement, allowing individuals affected by C9 or FR7-related disease to contribute samples and help expand the biorepository. Donations of skin cells from patients, including contributions from CureC9 co-founder Jentley Soto Albrecht and her late father, will be reprogrammed into iPSCs and differentiated into motor neurons, astrocytes, and microglia to model CNS cell types relevant to the disease. The plan is to standardize these iPSCs models for commercial use, enabling researchers worldwide to access them and evaluate potential therapies more efficiently. Researchers will gain access to standardized, commercially available models designed to accelerate discovery and therapy assessment. The biorepository will be developed by reprogramming donor skin cells into iPSCs and differentiating them into the key CNS cell types needed to study ALS and FTD. Overall, the partnership formalizes a scalable resource to study disease biology and explore therapeutic strategies while maintaining ongoing patient involvement. A Neanderthal-derived variant in the growth hormone receptor appears to boost the cellular response to growth hormone, contributing to small but measurable differences in body composition. In a study spanning more than 1.1 million adults across 5 biobanks, carriers showed about 270 to 285 grams more lean mass and were, on average, roughly 0.3 of a centimeter taller, indicating detectable effects on physique. Laboratory tests in mouse cells showed the Neanderthal receptor variant drives about a 40% greater growth response to growth hormone, mainly due to one of 2 DNA changes distinguishing Neanderthal from modern sequences. The effect seems to emerge later in development, around puberty, with no associations found in children up to age 11 in a dataset of over 6,000 kids. Researchers say puberty may amplify the variant's impact as growth hormone dynamics change, though onset varies among individuals. Led by Hugo Zeeberg and Philip Canis, the work was published in Current Biology in year 2026, with collaboration from Newsweek. The study highlights the value of science journalism and curiosity about how ancient genetics influence modern biology. While the lab estimated 40% signaling boost is clear, it does not translate into large real-world effects. The average impact remains modest. Experts note the lab results align with population data, supporting a real but small effect in people. This single genetic change is only one piece of a complex puzzle, with many factors shaping growth and body form. The Neanderthal variant cannot fully explain overall body type or appearance, as multiple genetic and environmental factors are involved. Carrying one copy from each parent could add about 500 grams of muscle mass, but this variant is not a substitute for training. A tiny insect is redefining scale in the natural world. The globe skimmer dragonfly, Pantala flavescens, about 1.5 inches long, undertakes migrations spanning thousands of miles and connects populations across continents. Rutgers researchers show these dragonflies cross oceans by riding wind currents, aided by wing adaptations that increase surface area for energy-efficient travel. The dragonfly's wing design, including a larger wing surface and an enlarged hindwing base, enables gliding and wind-assisted travel with minimal energetic cost, and freshwater-dependent reproduction aligns with seasonal moisture changes. Migration is tightly linked to reproduction, as Pantala dragonflies move to wetter regions to mate and lay eggs, sometimes journeying around 4,400 miles or more to find suitable breeding environments. Estimates place migratory reach over 4,400 miles, with transgenerational circuits spanning 14,000 to 18,000 kilometers between India and East Africa. Pantala flavescens now surpasses monarch butterflies as the longest-distance migrating insect, even exceeding historic feats by miles. A staged, multi-generational journey is suggested, with temporary freshwater pools serving as breeding stops that propagate an intercontinental travel narrative across generations. Lead author Jessica Ware notes that the lack of regional genetic differences implies extensive gene flow across oceans and continents, supporting a global panmictic population. Genetic data from dragonflies collected across diverse regions show strikingly similar DNA, indicating a single worldwide gene pool rather than isolated populations. The study analyzed 49 CO1 mitochondrial DNA sequences from samples worldwide, finding minimal genetic differentiation between continental populations. Precise migration routes remain uncertain due to tracking challenges on such small insects. Researchers rely on genetics and wing isotope data to infer likely paths. The Rutgers-led study in PLOS1 emphasizes the need for broader sampling and new markers to map specific migration routes, acknowledging that tracking devices are challenging to deploy on tiny insects. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.